Okay, now question 3 in this case, which is a rechargeable battery. Now this basically has both aspects of a spontaneous reaction and a non-spontaneous reaction, and when you're basically discharging, the battery operating normally, you would expect it to be spontaneous and have an E0 cell greater than 0, so positive. Okay. So anyway, so first part of this is deciding what's happening at the anode. Now this is talking about discharging. So this is a spontaneous reaction. So in this case, the more positive voltage will be getting reduced. So it's Ag2O going to Ag. Okay. And then obviously Zn going to ZnOH2, zinc hydroxide. So once you have that down, you can do the anode and cathode reaction and do the balancing. Now there's 2 silvers here, so there's 2 silvers on that side. There's 1 O on this side, so that means you've got to put water on that side. You put the 2 H pluses, and you've got to balance for charge, which means you put the electrons on this side. You always add the electrons to the more positive side, and that's that one balanced. Zinc going to zinc hydroxide. You've got you had 2 O's here, so you put 2 H2O's here. That means you had 4 H's. So you've already got 2 H's in here, so you have to put 2 H's here, and that's 2 electrons. So that's the cathode reaction for the discharge. Now remembering, when it comes time for the charging reaction, this is simply going to have this reaction being reversed, but instead of being at the anode, it will be at the cathode. Okay, the actual physical electrode never changes, it's just defined by what happens. So at the moment this is undergoing oxidation, so we call it the anode, but if we reverse it and it's undergoing reduction, we will call it the cathode. Okay. Now calculating potential, that's reduction minus oxidation. So this is a reduction value for the silver minus oxidation for the zinc, and that's going to give us a positive value of 1.55 volts. So now we're talking about recharge. So we've basically reversed this cathode reaction up here, and it's now going this way, but now it's happening at the anode, and the same thing, a similar thing for the cathode, reversed, and now it's at the cathode and going the other way. Now the overall cell, the overall reaction of the cell and being recharged, I don't think I've actually put there, so I'm just going to write that in now, and that's going to be just combining these. So it'll be 2 silver plus H2O plus ZnOH2 plus 2H plus, and that goes to Ag2O plus 2H plus Zn plus 2H2O. Now there's some cancelling I can do here. There's an H2O that can go, so that kind of goes there, so there's 1 left here, and the 2H pluses can go. Okay, so make sure you cancel. Alright, so now compare and contrast movement of electrons in these 2 processes. So effectively we've got to do those 4 bullet points, remembering we need to talk about discharging and recharging, or charging depending on how you look at it, I guess. So in the discharge, that's when it's spontaneous. The E cell value is going to be 155, so I'm commenting on this. It's going to talk about it being spontaneous. It must be greater than 0, and this is greater than 0, so it is spontaneous. And that means now I've got to talk about the electrons flowing freely and electrical energy being generated for that question. Oxidation reduction processes, I'm talking about what happens where the anode happens, oxidation takes place, 2 electrons are lost, so I'm being specific with the number of electrons. These electrons move from the anode through the wire to the cathode, so talking about the movement of the electrons, where at the cathode it's reduced and gains 2 electrons, so I'm being specific what it forms in both cases as well. Now oxidation numbers or electron transfer. Now I've kind of talked about electrons here as well, so I'm just going to talk about oxidation number here. So zinc has an oxidation number of 0. Zinc in zinc hydroxide has an oxidation number of +2. Okay, so make sure you're specific when you're talking about that. You can't just say the oxidation number of this is +2, because it's not. Only the Zn in it is +2. We've got to link that to an increase or decrease. That's an increase in oxidation number, so it's oxidized to zinc hydroxide. Again, the silver in silver oxide has an oxidation number of +1, while silver has an oxidation number of 0. That's a decrease, again using that key word, so it's being reduced. Okay, so it's just charging. Now charging, I'm going through the same process. Negative 1.55 volts. For it to be spontaneous, E cell value must be greater than 0. And as it's less than 0, it cannot be spontaneous. So linking spontaneity to the voltage, showing I understand what the E cell value means. It needs electrical energy. That's not enough though. I've got to talk about something else, but I'll do that later on. In order to make it spontaneous and have reverse the electron flow, I need some electrical energy to do that. So I'll skip down to that actually in a second. Now at the anode, oxidation occurs, and as a reaction is now reversed, silver is oxidized to silver oxide. It loses an electron when they're oxidized, the electron flow is reversed, and electron travels through the external wire to the cathode. While at the cathode, reduction occurs, and now zinc hydroxide gains 2 electrons to form zinc. Okay, the zinc hydroxide, now that's basically talking about the electrons in terms of the oxidation reduction processes, and so I'm making sure I mention anode cathode and talking about movement of electrons, and making sure I'm also talking about the fact that in this case the electron flow has actually been reversed. Now in terms of oxidation number, it's really just similar to what we said above, but just going the opposite way around, so I'll just leave it there for you to have a look at. One thing I haven't answered here though is an explanation of the role of the battery charger. So the battery charger causes the reaction to be reversed, so electron flow is reversed. That causes the reactants to reform, which is very important, because if they didn't reform they would run out and the battery would just stop. So the battery can be used spontaneously again. No, otherwise they would run out. So I'm going to stress an external power source, such as a battery charger, is needed. To supply electrical energy. Okay, and that is that. So I hope you found it helpful.